All right, ladies and gentlemen. So today we're going to do some recorded notes because the internet has been a little iffy with me today. So I don't think we're going to be able to count on it in class. So I'm going to run through a couple different examples of a couple different things. Hopefully, both of the two concepts that I go through here are review, and then you can be successful on your math homework when you do it. So the first thing that I wanted to remind you of is how to solve just equation, just solve an equation. So this should be extremely old hat for you guys, and hopefully it's pretty straightforward. But I'll write down the steps and I'll do a problem. You'll be practicing some of these as well, just to get us used to doing our algebra again, so that when we do real systems tomorrow, you'll be in a good place to have success tomorrow. So first, make sure you distribute. When you're distributing, you're taking anything outside out front of a chunk of parentheses and distribute it into the parentheses, multiplying it into the parentheses. So for instance, on the first part, this is a -1. The -1 part isn't there, it's just negative. You're multiplying -1 into there. That's a tricky one though. A lot of people forget to distribute that negative. They remember when there's numbers, like the 2 on the other side, but they forget about negatives. So distribute that -1 in. -7m plus, whoops, -12m. Negative times +12 is -12. Then we'll do the same thing. We'll multiply that 2 in. 2 -6. Cool. Step 2 is to combine like terms. I would maybe write some of this down too to make sure that you have notes that you can go through easily. We need to combine like terms. That means like terms on the same side of the equal sign. So for instance, 3m and -7m. 3 minus 7 is -4. 4 minus 6. Cool. We'd also combine any constants if there were anything to do there, but all of this now, we have all the like terms combined on the same side. Step 3 is get your variables to the same side. So we'll get our variables to the same side here. I'm always like to get mine to the left. It doesn't really matter, but remember, anything you do to the right side of an equation or you need to do to the left and vice versa. So anything you do to one side of an equation, do it to both. Kind of think of a dotted line going through there. If I do it to one side, I got to do it to the other. So I'm going to subtract 2 on both sides. I like to move my variables to the left. You could just as easily add 4m to both sides, but I'm going to subtract 2m to both sides. -4 minus 2 is -6. -12 is equal to -6. Cool. And then the last step, step 4, I just call it solve a two-step. If you do all those other steps, you should be down to a two-step equation. We almost always add or subtract our constant over first. So deal with that positive or that -12 first. If I do it to one side, I have to do it to the other. -6m is equal to a +6 now, and then I'll divide by -6. M is equal to -1. Hopefully that's all stuff you remember. It should have been fairly straightforward. This is stuff you did in Algebra 1 and some stuff you probably did in geometry, that kind of thing too. So go through there. I think you could do about 5 of those today. So expect those and get used to those. It'll just get our brains moving for algebra again. Cool. So that's just general first part of what we're doing today. The unit is actually about systems though, right? So systems of equations. First, we'll talk about 2 equations. So for instance, if I had a system of equation, that means that I have 2 equations at least with 2 unknowns, 2 variables, right? So it might look something like this. And Maybe it'll look something like this, right? So these are two equations. They both have an x and a y. They might not be always the same variables, but they both, in this case, have an x and a y, which means that we can solve these by graphing, okay? Or we can solve them algebraically. We'll do both, but for today, we're going to just focus on graphing and what that looks like in general. So what a system says is there's some place on here. So if I were to graph these two things, there's a place where these intersect, and that intersection point is what would solve both of these equations. So for instance, if I graphed this says that if you remember, our y-intercept is 3. I would go up 3. I'm not going to be perfect on these because I'll go through some examples where I am perfect. But I'll go up about 3. We'll call it there. So there's a point. That's my y-intercept, right, where it says y equals mx plus b. So that b, that end number is my y-intercept. That's up at 3. And then that says go up 2 over 1. This is my slope. The m there is my slope, up 2 over 1. So it would look something like this. And then at the same time, there's another equation. We'll put it in green here. So this one says, oh, my y-intercept is -4, so it'd be down here. And then this one says down 1 over 3. So down 1 over 3 would be more like this, nice and wide. Oops. So it'd be something like this, which means the nice part about this and the important part here is that this part right here, that is where those two lines intersect, and that's what we're looking for. That's the solution to these problems. So the solution to this system might be something, it's definitely not, I'm just making up some numbers here, but it would be an ordered pair, something like -6, -2. That doesn't really seem right, but we'd get some value like that. I'm not actually solving this one, I'm just reminding you in general what this looks like. Cool. So you'll get some point that it's an ordered pair of, let's just say in general, it's an ordered pair of x, y. Remember, all ordered pairs go x value, comma, y value in there. Okay, so that's the general plan for a system. There's also two other things that can happen, remember. Occasionally, you'll draw one of these and you'll get equations that look like this. And if those two equations go and they are what's called parallel, right? They have the same slope, they never intersect, this would be no solution. That's okay. No solution. That can happen. Maybe there is no solution where both of these two things would be satisfied. That's okay. Or what might happen is I graph one of these lines and it looks like this. But then I graph another one of these lines and it happens the same thing. Pretty decent, actually, right? I'd get right on top of that line. This would be infinite. Okay, so in general, that's the plan. I'll go show you how to do it, and then you'll be graphing these online, so you'll actually have less work than I did than I'll have to do for these next couple. But that's just a general overview of what systems look like, and then I'll go through and do a couple examples of graphing for you to practice today as well. Okay, so that's general systems. All right, so if I were to do this problem, they're both solved. Remember y equals mx plus b. So this is my slope, which is rise